Hey everybody, I just wanted to hop on real quick and give everyone a quick preview demo of my podcast generator that is built upon the OpenAI Realtime API. So in my last video, I introduced the Realtime API and I went over my custom Gradio app, and I'll give you guys a quick just refresh of that. And then we'll jump into our podcast generator that is, right now it's just a Python script that allows you to enter some subject matter and generate a quick podcast based on some settings that you want to set up. So let's get right into it. This is the repo for the OpenAI real-time voice chat that I built. It's a Python implementation of the real-time API. Theirs is mostly JavaScript, and I also have a Gradio app. So you basically have to set up an env file with your API key. So clone the repo, set up your env, and I have an example in there, so you can just remove the .example and convert it. And then I just hit CMD there and follow the instructions in the GitHub to install it, but we'll just spin it up real quick. .env/script/activate, and we'll do the main app first. So py main, and it will open up on your local host. You might be 7860. I'm on 7861. Looks like we need to update the Gradio version too. All right, so you'll open it on your local host. Mine's 7861, yours might be 7860. You'll record your voice. Hey, this is a test, just see if you're working. And hit submit.
I'm here and ready to help. What can I do for you today?
So there you go. This is stupid simple. Like, it's not even keeping history yet. I need to add a history object to it. I'm going to do that. But I wanted to, in the meantime, build a podcast generator. That's kind of was a little higher priority for me for the real-time API. So here it is, and I did open source this. It's on my GitHub under the podcast generator. So we'll run that one next. Just close out of that. And we'll close out. We'll keep in the same environment. And we'll just do a quick code walkthrough, right? So you authenticate with OpenAI, and here's how we, set up the URL, our headers, and everything. These are API calls that we're making, and not using a library for it. I also added Whisper in here because the way this works is with the real-time API, you basically can't give it the assistant voice back to itself. It will throw errors. So if you want to have the AI talk to each other to create a podcast, you have to resubmit and rebuild the conversation history in text. So we start with some source material. We give it some instructions. These are the instructions from Pliny on Reddit that were the original AI voice instructions. And then I give it a little custom piece right here that we're going to create a podcast based on the source material. This is some code to transcribe the audio. And right now I'm using the OpenAI API to do that because it's faster. If you have a robust GPU on your machine, you can certainly use local Whisper, and or just if you're not worried about time, then you can certainly use that. It just takes a little longer. And you can comment this out and turn this on to use Whisper. Otherwise, you don't need it. This is how you connect to the WebSocket for the real-time API. Here we get our, this is how we parse the audio response. So once you have your response built, then this is how we parse it. Let's go down to the bottom where we start. This is our main function. So the idea here is we start with a little starting text because we have to generate the first audio, right? So start with a short introduction to the material, and we need to specify some speakers. So these could be Alloy, Echo, or Shimmer. I'm not using Shimmer. And so I want it to go Alloy, Echo. So basically create a back and forth. If I wanted it to, it could be Alloy, Echo, Alloy, Echo, Alloy, Echo, Alloy, Alloy, whatever however many responses you want and whatever order you want the speakers in. That this is the essential line for that. So I could add to this, right? This is the list to build the audio responses, the list to build the history for the conversation. So the first thing we're going to do is send that text and receive back some audio. So we're going to send the text and send the first speaker. So Alloy is going to be the introduction speaker and the instructions, right? So let's go up here to send and receive audio. So what we're going to do is build we're going to connect to the WebSocket. And we're going to connect to the WebSocket, to a new WebSocket connection on every request. And the reason for that is I need to build the conversation history so we essentially don't pass back the voice as an assistant back to the API. Otherwise, you're going to throw an error and it's going to break your session. So we create a new session every time. I know it's kind of inconvenient, but that is the only way I could get this to work. If anyone else out there has better success or a different approach, I would love to hear it. That's kind of one of the reasons I'm opening this up is I think there's a lot of value here and it's fun, and I'd love to see what else other people contribute here. But so basically we build the initial message. It creates the conversation. The conversation type is input text, message from the user, and then we're going to create a response. There is a lot more you can do here with the response. Certainly go into the API and go to client events, and you'll go to conversation item create. And so here's where, and they have broken this, but here is, I don't know what happened to the OpenAI API language, but it's the links are broken now. But basically here you're going to conversation item create. And so here's what you can do with this. Here's the properties for item that you can pass in: user, assistant, system, content that you want to provide, input text, input audio, text or audio. Text or audio is the same as input text or input text audio. They just have multiple ways to do it. Okay, so we're doing input text, start text. That's how we start the conversation. Then we initiate a response. So once you've created a conversation item, you can create multiple. So after this, we're going to create a stack of those. But essentially, first we're going to create one, and then we're going to create a response back. Basically, ask. So these are client requests, right? So there's client requests, and then there's server responses or server requests, I guess we want to say. So we're going to create a response request. Here's the instructions. Here's the voice we're going to pass. And then we're going to get that audio response. So here's how we parse that audio response. And basically what we're doing is listening for events. So for the message in WS and the WebSocket, we're listening for these event types. So response audio delta means that there was a change in that, and there is some base 64 bytecode that is a part of the complete audio response. You could certainly change this code probably to stream that audio response back if you wanted to just listen to it. However, I want to build a complete MP3. So I am going to build a string for that base 64. And here's where I do that. So once that audio is done, I'm going to join all the audio parts. So I basically create a list for the audio parts. I append each delta response to the list, and then I join it all together at the end. Okay. And then I return that list, that string, that base 64, and I transcribe it. So I need the audio, but I also need the transcription, right? So we're going to collect that as history, the text, the transcription. We're basically building a history object as we go, okay? And the transcription, I already showed you that above, but we're going to get that transcription of the base 64 audio. So we have the transcription object and we have the audio. We could pass the audio back into the real-time API to get a transcription object. So I'm using Whisper, but you certainly could use the real-time API, but the real-time API is expensive. Every time I run this script, it's $1 at least. if it's a long prompt and I get about a couple minutes of audio, it's at least $1. So testing and building this gets extremely expensive. So that's another reason I wanted to provide this. Maybe I'll save you guys some money to get here. So we return back the audio reply and the history. Okay, so the history object. The history object contains the starting text and transcription. Okay, so now where are we at? We are back here into our main function, where if we got the audio response, we're going to append it to our audio responses. That's that list object. We're also going to append the history object back to a master history list. So this is basically a nested list. So you have a list there that has the user and the assistant. Okay, so the starting text and then you have the response. So we're going to create a conversation count. So for me, you want the user, and you want the response. You basically have a list of 2 with any of these. You could have a third speaker if you wanted to have a more robust conversation, but I want a conversation list of 2 speakers, okay? So I am going to go through this list and, basically create a loop through it. And I'm going to send audio and receive response based on this, these variables. So the last response audio, so that's basically the first response audio for the first response. And then we're going to change that last response audio on every loop to rewrite it. So we have the most recent audio response, because I can give back that to the API. But I can't give it back and say, here's assistant audio. I can give it back user audio, but I can't give it back assistant audio. So essentially we're tricking the API into thinking, okay, this is a new user talking to us each time. So I don't know if you lose some of the natural tone of the stack of the conversation, but you do take audio in and have audio back. And then the rest of the conversation prior to the last response is rebuilt in text, if that makes sense. All right. So let's go back and let's go review send audio and receive. So again, we're going to connect to the WebSocket for a new session. We're going to build a history response object list, and we're going to loop through the history object that we created. This is kind of pulled from Gradio logic, where you have a list of the user and the assistant messages. And so we're going to loop through for the, I'm calling it human and assistant here, whatever. It's AI1, AI2. And we're going to build a list object of the previous messages. All right. And it's going to create nested lists. So here's list 1, list 2, list 3, list 4, whatever. And it's going to append that, and it's going to extend that list to include each stack of previous messages. So you're going to have the entire list of those. And then we're going to send that back to the WebSocket. And that's going to create this conversation. All right. We could probably add this to it as well. I have it as an extra step. You can basically, keep updating the conversation. So then we're going to come here, update the conversation with the audio message, and then we're going to request a response or create a response back, just like we did in the original, except for the stack is now built with the conversation text history plus the last audio message, and then we're going to get that response back. All right. Get the bot reply, same thing. We're going to reply back with a reply to the transcription. And we're going to do that for every speaker that you have in the list. So if you wanted to add more, it's going to continue this loop until you get to the end. For every other response, you're going to build this history object. And then at the end, we combine all the audio back. And then we create some little natural pauses in between the speakers. Otherwise, the speakers run over each other or up into each other, and it's a little less natural. So creating these pause durations there also, adds to some naturalness. You can kind of play with that. All right, now that we've got here, let's run the program. Okay, so all I did was for this generation. Let's go back up to source material. I went and pulled some Wikipedia article here about ChessMac. I don't know. It was a suggested article of the day. And I just pasted it in. You could certainly add a function here to web scrape or, get whatever source material you wanted from a document, copy paste, add a UI for this. I might add a UI for it if it's popular, whatever. But essentially run podcast generator. So let's run it. We're in our environment again. Podcast generator, and it doesn't take very long. A couple, seconds. It sends the first request. You get your audio delta. First transmission's complete. So that's the first response. There's our list. There's our list of lists with the user object. Here's our second response. That one's complete. Here is it's rebuilding the conversation again. And here is our third. Now see it start to get longer. And here is our last one. So, and then you get to MP3 saved. So now let's listen to it.
Welcome to our discussion on ChessMac, a pioneering computer chess game from Finland. Created by Reimo Suonio for the Telmac 1800 computer and released in 1979, ChessMac holds the distinction of being possibly the first commercially released video game in Finland. Its development, gameplay, and historical significance offer a fascinating glimpse into the early days of video gaming. Join us as we explore ChessMac's unique journey from concept.
Absolutely, ChessMac is a fascinating piece of gaming history. Reimo Suonio's creation of...
I see there was a clipping there. The streaming API sometimes clips audio. I don't think it's a bug with the logic of the code. I have really went through this, and I noticed it on the responses back, just in raw, decoding the raw bytecode. Occasionally there is clipped responses. So, use it at your own risk. Again, that was $1 to run this.
On the flip side,
probably 80
was
cents.
Like a bonus Easter egg for anyone who got a hold of that.
The final picture would turn out as planned until it was run on the computer. And let's not forget how adding extra features like the game of life on the B-side added so much value and fun. It's fascinating.
Okay, now, is there value in this beyond novelty? I don't know. I use, for my podcasts that I put out on YouTube, if anyone's familiar with those, feel free to go back and look up some of my history. I do a new video every day using like the Wikipedia featured article. And I use 11 labs and a little different stack. It's more manual, and but I'm really interested in new avenues and like new ideas to build that better. It's been something I've been working on for literally years now, and yeah. So this is the newest flavor of it. I think there's some merit here and definitely worth exploring. I wish the costs would come down. This is super expensive to develop with. OpenAI, please help the developers out. Like, it's so hard to, I'm not trying to get quality stuff. I'm just trying to build the stack, and there's very little instruction on this. Like the API reference is all JavaScript. This is just the raw JSON responses. But if you go and look up at the real-time introduction, the examples. Let's see, I think I was go back a couple steps here, but the examples all are JavaScript, and it's challenging to build upon it when you have to spend about $1 for every stack of a conversation. So I'm excited about it anyway. I think there's a lot of cool stuff here and a lot of really awesome stuff to come. I look forward to any questions. I will leave links to my GitHub repo in the description, and also links to all the references I used here. Thanks for tuning in. Have a great day.